In this video, we're going to simplify a complex fraction that doesn't really look like a complex fraction at first glance. So, number 38 here, all of these different variables have negative exponents, which if we remember our exponent rules, means this actually should look more like this. The negative exponent brings that base to the bottom of its respective fraction and changes the exponent to a positive. So we look at this, and now what we want to do is multiply everything by the least common denominator. Since a is a common factor of a squared, I don't need to multiply by a and a squared. I need to just get everything that has a common factor of a squared, similarly with x squared. So I'm actually going to multiply top and bottom. You can do a blanket statement, or you can do a little bit of upfront work to avoid having to do a lot of simplifying at the end. So for this top 1 over a fraction, I'm going to multiply by a on top and bottom to deal with that a squared. And then I also need an x squared, so I'm going to have x squared. Basically, the exact same logic is going to dictate that because these are x's, I'm going to multiply by a squared x on top and bottom. Okay, the 1x matches with that x squared that's also highlighted, and the a squared is because everything has an a squared. Now, in the bottom half of the big fraction, I'm going to multiply by, well, I already have the a squared on the bottom, but I don't have the x squared. So I'm going to multiply just by x squared, and then similarly just by a squared. I did a little bit of upfront work. What it's helping me to avoid is basically what I'm going to write out anyways, is this would give me ax squared over a squared x squared minus a squared x over a squared x squared over x squared over a squared x squared minus a squared over a squared x squared, which is really, really ugly. But because these are the same and those are the same, this is ax squared minus a squared x over a squared x squared over x squared minus a squared over a squared x squared, where this is the same green and that's the same blue. And because those two are the exact same, this is now ax squared minus a squared x over x squared minus a squared. Okay? This is super, the word I'm looking for. It is abstract. There's not a whole lot of numbers that we're seeing here, so it looks really confusing, but we're just kind of tracking where these different parts of our fraction go. I always want to try to simplify this remaining fraction if I can, which means I need to try to factor some things. Okay, on the bottom, I know that x squared minus a squared is a difference of squares, so I could write that as x plus a times x minus a. Okay, on the top, I need to try to find something that might cancel with one of those, if I can. It's not guaranteed that I can, but I'm going to try. So the first thing that I notice is that they both have a common factor of a. They both have an a, so I can start with an a. That leaves me with an x squared minus ax. Well, similarly, they also both have an x, so I could factor out actually an ax to be left with x minus a on the top. So on the bottom, I have an x plus a times an x minus a. X minus a's cancel, and I'm left with just ax over x plus a. So this problem is a lot of mental gymnastics because we don't really have any numbers that we can tie ourselves to see, okay, 3 is going to do whatever, 5 is going to do whatever. We just have to follow the patterns. Okay, this simplifying of complex fractions is very pattern-based. If you can get the top of the big fraction to have a common denominator, and the bottom of the big fraction to have a common denominator that matches the other one, you get to take it from one fraction that's really big with two fractions inside of it to just one single fraction. Now you factor and simplify. If at the beginning, and this is a perfectly valid thing to do also, if I had started and just said, I'm going to multiply everything by all of the bottoms, okay, except for the one that it had. So 1 over a, I'd multiply by a squared x squared. That's perfectly fine. The 1 over x I would multiply by a squared, x squared. That's effectively doing the same thing, but you're introducing a spot that already could have been simplified. Because that's going to cancel, that's going to cancel, that's going to cancel, that's going to cancel, right? You're going to have all of these different things that can cancel that we don't really need, and you're just making it so you have more work to do at the end with simplifying. This last step here, getting this thing factored, is already complicated enough. If you multiply by extra things, you're going to have polynomial expressions of degrees 3, 4, 5, 6, whatever it may be. So if you can find the least common denominator first, multiply top and bottom to get to that, that's going to make your life a lot easier. Not easy, but a lot easier. Have a great day, everybody.